Here we'll continue looking at measurement, specifically looking at units of area and how to find the area of rectangular shapes. Our intentions today are to learn how to convert between basic metric areas and then to find the areas of squares and other rectangles. And we'll know that we have done that when we can in fact convert between metric areas and find areas of squares and other rectangles. Our key ideas today are to firstly look at the basic metric units of area. These include 1 square millimetre, which we show as 1 mm squared or 1 millimetre squared, and as you can see it is quite small, so if we zoom in on that we see that the sides of that square are both 1 millimetre. 1 square centimetre, which we can see has side lengths of 1 centimetre each, and we can say that 1 centimetre squared is also the same as 100 millimetres squared. And if we think about that, 1 centimetre is 10 millimetres, so if we were to redraw this square and instead of 1 centimetre say 10 millimetres, we would have 10 millimetres on this side here. And as we'll see in a moment, the area is worked out multiplying those two together. So of course 10 times 10 is 100, so we'd have 100 millimetres squared. So we've just proved that 1 centimetre square is the same as 100 millimetres square. The next common one is a square metre. Sorry, that should be 1 metre squared without the second m there, sorry about that. And again, 1 metre squared is the same as saying 10,000 centimetres squared. Then we have 1 square kilometre, which is the same as 1,000,000 square metres. And there's also a special area measurement that we use in metric. It's called a hectare. Now notice that we don't say 1 square hectare here. A hectare by definition is a square area. So 1 hectare is the same as 10,000 metres squared, or as the picture shows, a square shape with 100 metre sides. So it is a little bit of a special one, but it is one that we need to know. So 1 hectare is 10,000 square metres, or a square shape with sides that are 100 metres each. We also need to understand what area is. So area is any rectangular shape, area of a rectangular shape can be found by multiplying the length times the width. Remembering that a square is a type of rectangle where both the length and the width are the same. So we could just say length squared, or width squared would be the same. So we see that as area being a capital A equals L times W, which represents the length times the width. This also works for numbers that are not whole. So of course you can have sides with decimal values. So it's time to head off and do some questions. These are the ones that you're asked to do at the moment. And as usual, we'll go through them in the next part of the video. Either go ahead and try the questions for yourself first and come back to look at these samples if you need to, or you may choose to watch them first. That is up to you. Question 2 asks you to count the squares to find the area on this 1 centimetre grid. Now it's important to note that it's not to scale, but each one of those blue squares is representing 1 centimetre of square. So if we have a look at this grid, we basically have 1 here in this centre section, and then we've got this triangular shape. Now if we were to take this section here and redraw it, it fills up this section here. So what we have is the equivalent of another full square. So if both of these squares are 1 centimetre by 1 centimetre, then we have 2 1 centimetre square grids. So we have 1 centimetre square plus another centimetre square, which of course equals 2 centimetres squared. So that's a fairly simple question, so long as you can recognise that that little triangular piece is the same as what's missing from the other one. Another way you could think of that is if I redraw it over here for a second in these extra squares, we have 2 square centimetres there, so 1 square centimetre here and another one there, and they're being divided, if you thought of that as a rectangle, they're being divided down the middle. So if these were both a square centimetre and we've got half of it being used, then obviously between those two, we're actually only getting 1 centimetre square. So it just depends on how you look at the picture as to how you can tell what it is. Question 3 asks you to find the area of the rectangles and squares. So the first one is quite clearly a rectangle. Now we know that the formula is area equals length times width. Okay, generally we think of the length being the one at the bottom, width being the one vertically, but it doesn't really matter. So let's rewrite the equation to be equal to, we'll take length to be 2 and the width to be 11. So of course that is equal to 22. And don't forget to put the millimetres because that's the unit of measurement. And it's very important that we show the square now. If we just said 22 millimetres, that's not the area. We have to make sure that we put the little square symbol in. Now a second one might initially not look like something you know, but of course it is a square. It's just rotated. Now we know it's a square because on each of those sides there is a little mark, and from the earlier chapter we know that those marks indicate that those sides are of equal length, and if all 4 sides of a shape like this are equal length, then it has to be a square. It doesn't matter that it's a little bit crooked at the moment, or turn on its side a little bit. In this case, it has to be a square. So that means that all of those sides are 2.5 millimetres. So again, let's write out our formula. Area equals length times width. Replace those with 2.5. So 2.5 times 2.5. And we can do our maths. Now, if you've forgotten how to do multiplications of decimals, you might want to go back and have another look. But remember, we just treat them without the decimal places to begin with. So just over here, I'll do 25 times 25. Okay, 5 5s are 25. 5 2s are 10 with the 2 is 12. And now 2 times 5 is 10, and 2 times 2 is 4, plus the 1 is 5. Add those together, so I get a 5, a 2, and that makes 6. So over here I have 6, 2, 5, but now put back in the 2 decimal places, 1 from each of these numbers here. So there's my decimal place. So I have 6.25 millimetres being the unit of measurement, and not forgetting to put my square symbol in. Now, just a little thing here. This is a topic where I will start to be okay with people using their calculators to help with the calculations. It would always be good to try and either do them mentally or on paper if possible, but I have no problems with you starting to use your calculator to check your answers and to help with the more complex ones. Question 4 says to find the length of a square with this particular area, and you can use trial and error if needed. So I always recommend again that if this is a worded problem, that you need to draw a diagram to help you visualize what's going on. So the first key word here is it is a square. So I'm going to draw a square, all right, and I know that the area equals 16 centimeters squared. So what I'm looking for is what is my length and what is my width, remembering that all of these sides are equal. That's going to give me a value of 16. So I'm looking for what number multiplied by itself. So remember, area equals length times width. And if they're both the same, what number multiplied by itself is going to give me 16. So I can go through some numbers. I might say, well, what's 2 times 2? Oh, that's going to be 4. That's no good. What's 3 times 3? Well, that's not going to be good. So I can do trial and error, or I might know my times tables. I might know a little bit about square roots, possibly even. But I'm looking for a number that will work. In this case, if I say that each of those are 4 centimeters, then my formula for area becomes 4 times 4, which of course is 16, remembering centimeters and squared. So what I found is the length or width that I need, the side measurement, is 4. Now this is a worded question, so I should probably provide a worded answer. So the side measurement is 4 centimeters. Now remember, that is not squared. the squared is when you talk about the area. This is a side measurement. Question 5. It says there are 10,000 meters squared in 1 hectare. It wants you to convert these measurements to hectares. So we have a number here of 40,000 meters squared. We want to know the number of hectares. So essentially what we want to do is divide the number given by 10,000. So again, 40,000 divided by 10,000. Now there is a better way, of course, to do this, but we might even just be able to look at that and go, well, 40,000 divided by 10,000, that's going to be equal to 4. So we're going to end up with 4 here, which of course is how many hectares there are. Okay, so there are 4 HA is fine, that's the abbreviation for hectares, in 40,000 meters squared. Again, there is no squared on hectares because hectares by definition is an area. It is already squared. We don't have to write 4 hectares squared. Question 7, another worded question. Glass is to be cut for a square window with side length of 70 centimetres. Find the area of glass needed for the window. So again, it's a good idea to draw a diagram. So again, I'm drawing a square because it tells me it's a square and the side is 70 centimetres. Again, I'm going to indicate that all of these are the same because it is a square. So my formula for area, of course, is area equals length times width. In the case of a square, length and width are the same, so it's equal to 70 times 70. So 70 times 70, of course, is going to be equal to 4,900, and that is centimetres square. Question 9. A square has a perimeter of 40 centimetres. Find its area. So again, let's draw a diagram. It's a square again. It told us that it is a square. What we have here is we know that the perimeter is 40. All right, so let's mark all the same. So P for perimeter equals 40 centimetres. So perimeter, remember, is the distance around all the outside measurements of whatever shape. Because this is a square, all sides are the same. So to find one side, we can say the perimeter, which is 40, divided by 4, because there are 4 sides. Well, that's obviously going to be 10. So we've worked out that one side is 10 centimetres. Therefore, all sides are 10 centimetres. Now that we know the side measurement, we can find our area. So area equals length times width. With a square, they're the same, so it's equal to 10 times 10, which of course is equal to 100. Don't forget the unit, and don't forget the squared. So this square, which has a perimeter of 40 centimetres, will have an area of 100 centimetres square. Question 10. Carpet costs $50 per square metre. A room is rectangular with a length of 5 metres and a width of 2 metres. What is the cost to carpet this room? So again, let's start with a diagram. So it has a length, it's a rectangle, sorry. So I'm going to draw a rectangle. And the length was 5 metres and the width is 2 metres. So drawing that diagram helps me to visualise what I'm doing. So now I can work out the area, which is equal to length times width, which is equal to 5 times 2, which of course is 10, and that is metres squared. So we know the area of that rectangle room now, but what we want to find out is the cost to carpet it. So it says that for every square metre it is $50 up here in the question. So we have 10 square metres, so what we want is our cost is going to be equal to the amount per square metre, which is $50, multiplied by how many square metres we have. So of course that's going to be, start with a 0, 1, 0, 0, and 1, 5 is 5. So of course that's 500. Don't forget though, it is dollars, and it is a worded question, so let's write a worded answer. So we'll say it will cost $500 to carpet the room. So a few steps there. First of all, find out the area and then multiply that area by the cost for each of those square meters of carpet. Question 11. Sasha wants to paint a wall that is 2 meters tall and 5 meters long. 3 coats of paint are needed. The paint is only available in 1 litre amounts, with each litre covering 20 meters squared. How many litres of paint will need to be purchased for this job? Now there are several steps to this, so let's take it bit by bit. We're painting a wall that is 2 meters tall and 5 meters long. So let's start with our diagram. So we have a wall. It is 2 meters tall and is 5 meters long. We're going to be painting, which means we're going to be covering it. So we're talking about area here. So let's work out the area first. So area equals length times width, which is equal to 5 times 2, which is 10 meters squared. Don't forget the meters and squared. Now, that's the first part. We need to do 3 coats of paint. So what we've worked out is the area for the wall if we did 1 coat. If we need 3 coats, we're going to take our area, multiply it by 3. So that is going to be 10 times 3, which of course is 30. So it's going to be 30 meters squared in total because we have to do the wall 3 times. Now, it says that paint is only available in 1 litre amount. So we have to buy the full litre. We can't get a part. So we're not going to be looking for decimals here. And each litre that we buy covers 20 metres. So basically we're looking at how many multiples of 20 are in the area that we need, the total area being 30 for the 3 coats. So obviously 1 litre is going to cover 20 metres, but we still have to buy a second litre to cover the last 10 metres. So we're going to use we're not going to use the whole 2 litres that we buy because 2 litres would technically cover 40 square metres of wall, but altogether we only need to cover 30. But we have to buy the full litre. So we can say that we will need to buy 2 litres of paint to cover the 30 meters square, something like that. So again, the trickiest part here is not the area or any of that, it's remembering that you have to buy the full litre. Some people might write buy 1.5 litres, and that would be wrong because you can't go and say, can I have half a litre? It tells us here that the paint is only available in full litre amounts. Okay, so watch out for words like that. Don't get tricked into it. Question 13 says, find the missing length for this rectangle. So here we have a rectangle. It's given us one measurement here as 5 centimeters, and we've got the area as 50. So again, we think about what we've got here. We've got area equals length times width. We have the area, and let's say we have the width here. So we've got length times 5. That's an L, not a 1. So what we're trying to say is what multiplied by 5 is going to be equal to 50. That will tell us what this question mark is. In fact, let's write it like that. 50 equals question mark times 5, if it helps you to see it better. So most of us will be able to look at that and go, oh yeah, something times 5 equals 50, it's going to be 10. Later on, we're going to talk about ways to rearrange an equation so that we can find the missing value. But for now, we're really relying on our knowledge of times tables and simple multiplication to go, oh yeah, something times 5, it's got to be 10. So what we can say here is the question mark is equal to 10 centimeters. All right? And if you want it to be really short, you put it back into your equation. So you say area equals length times width, which is equal to, in this case now we're saying 10 times 5. And of course, that comes out to be 50. And we say centimeters squared, of course, because we're talking about area. Question 14. Explain why the shaded area of this diagram is 8 centimeters squared. Now, if we think back to the first question we did, we kind of already answered this, but let's look at it again. we can tell by looking at this shape that each of these blue squares must be a 2 by 2 centimeter square, because this measurement here is 2 centimeters. They're squares, so that must mean one of these is 2, and we've got 4 of them in total. That's where we get our 8 centimeters from. So each one of these individual blue squares is 2 centimeters. Now let's just think of that as a full rectangle. So we're talking about the whole rectangle around the outside of the shape. Not just the shaded, but the full one. So if we had the full one, the area of that would be equal to 8 times 2, which would be equal to 16 centimeters squared. Now it's very obvious that this is being divided from one corner to the other. So it's been divided exactly in half. Okay, so if we know the full area, we can simply say that the triangle is the area divided by 2, right? Or we could say area divided by 2 this way, because we're doing half of it. So of course that would be 16 divided by 2, which of course is going to be equal to 8. So 8 centimeters squared. So mathematically that's how we can do it. But again, it's because we can recognize the shape being a rectangle, we know how to find the area of the full rectangle, and we therefore can also see that by the way that we had drawn that line from corner to corner, it must mean that half of it is shaded, so we can simply divide the total area by half. We could also look at the shapes and go, yeah, we can see that this part here must fit in here, and this part here must fit in there. But really, knowing the full area is a lot more efficient, and being able to divide it in two, because we can see the way that this line runs directly through the center of it. So that's all the questions for today. As always, have a go at them yourself. If you need to, come back and watch these examples as many times as you like. And if you've got questions,